deep in the furnace of a dying star. Eons of fusion have created iron, and as the nuclear furnace is cooled, a sudden and violent explosion spread the iron across the cosmos. Over the next few billion years, these heavier elements accreted into this place that we call the Earth. Time passes, and humans discover this iron deep in the Earth and discover its mystical properties. They discover ways of forging this iron and create one of mankind's greatest inventions, the truck stop knife. This is where the story of iron ends, and my story begins. This is JJJinks Truck Stop Knives! JJJinks Truck Stop Knives! And I'm here at work to do a little video about some of the tools that I use in the lab. I've been pretty negligent about making videos lately, so I figured, well, I got a little bit of time right now, so why don't I tell you about some of my work tools. I'll start off with a knife. So this is just a cheap steel, I'm not really sure what it is. It's just it's a Warncliffe style knife, meaning that this flat part is actually the cutting edge. It's made by Arthur H. Thomas in Philadelphia, stainless steel, and we mostly just kind of use it to cut samples, anything from paper, wax. We get all kinds of weird stuff in our lab. So that's one of the knives that I have on my job. But other than that, we pretty much have safety blades, box cutters, and stuff like that. So if I do laboratory knives, that's pretty much the end of the video. It wouldn't be very fun. So I'm going to tell you about some other tools that I use. Here's one. These are tongs, and we use them to pick up stuff. These tongs are kind of special because, as you can see, the tip is this metallic looking stuff, and the purpose is that they can be very easily sterilized. You can hit it with a flame to burn off stuff. You can dip these things into acid to get rid of any residue from the flame, because it's usually butane or propane. It leaves a residue of organic stuff. And we use it to pick up things like this. This is called a crucible. It's basically just a fancy cup. Now this tip is made of platinum. And then this crucible, also made of platinum. So the materials are compatible, and I can pick it up and carry it around and put my sample in it and do what I gotta do without any fear of contamination. I've also got this one, also platinum tipped, but it's kind of a sinister looking stinger thing, but it's really great for picking up stuff like so, and I can move it around with a lot more control. Other crucibles that I have, we use them for basically burning stuff. I can mix some solids with a little bit of acid, or maybe just put it onto a hot plate or into a furnace, burn off everything, and whatever's left behind is what I'm interested in analyzing. But sometimes platinum doesn't work. There are some materials that don't eat the platinum. So some other materials we use these a lot. These are made of porcelain. These are made from aluminum oxide. So they're kind of expensive and kind of fragile, but you can get these really hot, like thousands and thousands of degrees centigrade, almost like 7,000 degrees Fahrenheit or something like that, and they won't melt, they won't break. So this one's really expensive actually. It's made out of something called Vicor, which is a light glass that can also go to very, very high temperatures. This stuff is great for things that are very acidic or will otherwise react with the vessel, and this is pretty inert. This one's a little different. This is actually what's called a Coors dish, and this is made of Teflon. These are also kind of expensive just because it's hard to get Teflon into a shape. It's got to be molded this way, and you can actually get things pretty hot in these. You can boil water in these if you want. We also have a bunch that are made out of steel. This one's pretty corroded. And this one's made of stainless steel, so it's coated in chromium oxide. This one is worth its weight in gold, because it is. So, when we're moving liquids around and we want to use small quantities but with a lot of accuracy, we use tools like this. This is called a pipette. And the way it works is you got this little dial on the side with numbers on it, and you can twist this top to change those numbers into whatever volume you're dialing in. And then this top piece that you use to dial it in is actually, there's a piston inside that it actuates, so you can suck up a very small amount but measured volume of liquid. Now, of course, you don't want to use this directly because it'll contaminate with everything you put in it, so we use these tips that we affix to the end, and then you just throw these away when you're done. We also have another kind of pipette. If we want to move small amounts of liquid, but we don't necessarily want it to be, too accurate, we just want to move it, we use stuff like this. These are called Pasteur pipettes, which you get the little squeezy bulb on the end. These are made of plastic, and you can suck things up. They also make these out of glass, where you put like a little bulb on the end, and you can do it that way. They're disposable. You use them once and you throw them away. It's great. And I just also happen to find a glass stirring rod nearby. This is just a glass rod we use to stir things, and glass is pretty inert, so as long as you don't care about having silicon in your sample, you can use this to stir things up a bit. Moving on. Well, I've moved on to the next room, and there's all kinds of goodies in this one. So, just kind of laying around on the bench top here, we have this curious looking device. This is called a degausser. Basically, it discharges electrostatics. So if you're working with fine powders and they kind of fly around everywhere, this will discharge the magnetic field on your glass vial or whatever you're trying to get it into. We got Sharpies all over the place. I prefer the ones with the clicky tops, because you can use them one-handed and don't have to worry about a cap. Electrical tape, we use that for all kinds of things. Here we got a plastic funnel, also very useful. Now this area is used mostly for preparing powders. So we have various brushes. These are just paint brushes that we can use to kind of sweep away small amounts of powder. And we got these spatulas. These are like the kinds you'd use to, mix up a little bit of cake batter. It's good for smoothing and moving powders around. Here we got a smaller one. And these are just made out of stainless steel. And then over here we have a small collection of spatulas and tweezers. So we have some fine tweezers that we use to tweeze fine things. And this, also for moving powder around, this is actually called a scoopula. Let's see. We have jars of other things. Here's a more traditional type spatula. Just kind of a flattened piece of metal on both sides, and then a round part in the middle for gripping. And we also have same thing, sort of, except it's just a little scoop at the end, and there's a green coating to give it some chemical protection. Another kind of tool that we use a lot is this pointy thing here. It's called a probe. Here's an example of a sample. It's basically just a pile of particles or something, and let's say you wanted to analyze just one of those. You can use the probe to get it to stick to the end, and then you can move it to your microscope or electron microscope or whatever. And we have all kinds of different types of probes. Here's a nice wooden box with all these different probe tips. There's one that looks like a Pac-Man going up, and a couple of them that look like medieval torture weapons. So we have a whole bunch of these tools that we use for various types of samples. And here's a mirror on a stick. So I've been disposing of some acidic waste by pouring it into basically water and baking soda. And I've been kind of doing it slowly. So there's a pile of solid sodium bicarbonate on the bottom. And you can see it kind of looks milky. That's all bubbles because of the reaction. So what I'm going to do is very slowly with this stirring rod here, disturb the surface of the powder at the bottom, and the whole thing should blow over. There it goes. Fun part of the job. A lot of the equipment we have is safety related. So for example, here's a fireproof cabinet. And inside is a crap ton of chemical waste. I've generated this over about a week and a half. My carbon footprint is enormous. And here we have an ancient bottle of boil easers. These are basically just little porous stones, kind of looks like cat litter. And you add it to things that you're trying to boil so that it doesn't bump, where it will sort of boil all at once and foam over. These will kind of get it started for you. And I wonder if there's a date on this. I have no idea. I can't even get it open. It's like sealed shut. I don't know why we have it still. So that was a glimpse into some of the toys that I get to play with. Being a scientist is a lot of work, but you get to use some really cool stuff and do some really cool things. I wish I could tell you more, but we have to keep our clients confidential. Otherwise, it's bad for business. Anyway, until next time, this is JJJinks Truck Stop 9.